Hello and welcome to a ramble, a nostalgic math chat with me. We are busy with IEB paper 1 from November 2022, looking at question 11. Almost at the end of this paper. Woohoo! In the diagram below, C and D represent two drones on the ground. The drone at C has a flight path modeled by f of x is equal to minus x squared plus 2x plus q. The drone at D has a flight path modeled by g of x is equal to mx plus 5. CD is 7 meters and AB is 2 meters. If point E is directly above C, calculate the length of EC and show all your workings. Okay, so we have this parabola here, which is f of x is equal to minus x squared plus 2x plus q, and this straight line here, which is this guy, g of x is equal to mx plus 5. CD is 7 meters and AB is 2 meters. Okay, and then we're asked if point E is directly above C, calculate the length of EC. Okay, so this is what is coming up for me on a second read. So we don't know the gradient of this line, but we do know its y-intercept. So we know the coordinates of B. That'll be 0, 5. And so then we know the y-intercept of the parabola. That'll be 2 units down from there. So that'll be 0, 3. And that will give us this q. If we sub in 0 over here, that gets rid of these terms. So that means the q has to be the 3. And once we know the equation of the parabola, we are able to figure out the coordinates of C, its x, one of its x-intercepts. And then we just need to figure out the coordinates of E. It shares an x-coordinate with C because it's directly above it. And then we need to put it into this equation to figure out its y-coordinate. But we do not know the gradient. Oh, but we can figure that out because once we know C, we know that D is 7 meters later, so we can figure out its coordinates using that and use that to figure out M. Okay, so it's messy, but let's do it. Okay, so first and foremost, B is the y-intercept of G, therefore its coordinates are 0, 5. A is 2 units down from B, therefore A will be 0, 3. And so therefore f of 0, which is minus 0 squared plus 2 times 0 plus q, is equal to 3. So that means q is equal to 3. So we can now figure out the coordinates of C. So to find C, we are going to solve where is f of x equal to 0. So the equation is minus x squared plus 2x plus 3, and we need that to be equal to 0. Gonna times through by -1, so that it's a bit easier for me to factorize this. Nothing stopping you from doing it with the coefficient of x squared being -1. So either x is equal to 3 or x is equal to -1. But the x-coordinate of C is greater than 0 because of, it's on this side of the x-axis. And we're talking about, okay, no, never mind. So therefore, x is equal to 3. And I am going to now move this question to the next page. Okay, right, so now we can come up to this side. Okay, so we now know, therefore the coordinates of C are 3, 0, right? Okay, and therefore the coordinates of D are 3 plus 7 and 0, so that is 10 and 0. Okay, and we can use that to figure out the gradient of M, the gradient of G. So we know that when x is 10, the function outputs 0. So M times 10 plus 5 is equal to 0. So 10M is equal to negative 5, and M is equal to negative 5 over 10, which is negative a half. So therefore G of x is negative a half x plus 5. And now we want to find the coordinates of E, and E has an x coordinate of 3, the same as C. So xe is equal to xc is equal to 3. So now we're going to find, well, what is the value of the function when x is equal to 3? It will be minus a half times 3 plus 5. It will be minus 1.5 plus 5, which is minus 3.5. Not minus 3.5. It will be positive 3.5. Right. And so therefore, the length of EC will be 7 over 2 meters, and that's the unit we're dealing with. Right. Awesome. Okay. Let's just get the picture again. Okay, so we now know that this is minus a half x plus 5. And we also know that this over here is a 3. And we know the coordinates here are 3, 0, and this is 10, 0, and this is 3 and 7 over 2. Right? Okay, cool. The next question says, a friend of yours says the vertical distance between flight path DB and flight path CA will never be less than 40 centimeters. Is your friend's statement correct? Okay, so we can see that this parabola is always below the straight line. I know they say we shouldn't treat these diagrams like they're drawn to scale, but I really don't want to go through the schlep of showing it mathematically. Either way, it's fine. We don't actually care. We can start off by looking at the difference between g of x and f of x, and if this friend is right, then that means this difference is always going to be greater than 40 centimeters, in which case that also inadvertently proves that this parabola is always below the straight line, because if it wasn't, then at some point the difference between g and f would be a negative number, because the parabola would be higher than the straight line. So it's fine. We don't have to establish up front that the parabola is always below the straight line. We're just going to start out by assuming it, and then we're going to see, well, is there what is the smallest possible value for this difference, also given that we are only looking, I'm guessing that the 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 paths stop here, they don't go further. Either way, it doesn't matter because now the parabola is going to go down, the straight line will keep going up, so really it doesn't even matter what domain we're looking at. So yeah, I'm not going to restrict that up front either. Okay, so we're going to look at the difference. So let's say let's let d of x equal to the difference between these two functions, which is minus a half x plus 5 minus x squared plus 2x plus 3. Okay, that is plus x squared minus 2x minus 3. So that'll be x squared minus 2x minus a half x is minus 2.5, or minus 5 over 2x. And then 5 minus 3 is positive 2. Right, so this is, if we're to look at this, this is a parabola. Let me just quickly see where the turning point will be. So it'll be b over 2a, so minus 5, wait, it's minus b over 2a, so minus 5 over 2 over 2 times 1, so it's going to end up being a positive number. And will it be above or below? It doesn't really matter. I mean, it kind of does matter actually. So this will be 5 over 2 is positive 5 over 4. And then if we, okay, I should do this formally actually. So right, if we are looking at the value of d versus the x, I am just interested in where that turning point is. I mean, first of all, I know that the y-intercept will be 2, right? Because it's 0 squared minus 5 over 2 times 2. No, man, not times 2. 0 plus 2, so that will be 2. So that will be the y-intercept somewhere at 2. And that checks, right? That tracks because at x is equal to 0, the distance between the drones is 2 meters. So that, yeah, that checks out. So now I'm interested in where the turning point is and whether it will be above or below the x-axis. So the x-coordinate of the turning point is given by minus b over 2a. The b in this case is minus 5 over 2, and the a is the coefficient of x squared, which is 1, and that just ends up being 5 over 4. So then the y-coordinate of the turning point is going to be 5 over 4 squared minus 5 over 2 times 5 over 4 plus 2, which is 25 over 16 minus 25 over 8 plus 2, and that is 0,4375. So this is going to be a graph that looks like that, where at x is equal to 5 over 4, this is where they're going to be the closest possible. G and F are going to be the closest possible, right? This is where they are there's the smallest distance between them, the minimum distance between them, and that distance is 0,4375 meters, right? So the closest that the drones will ever be to each other is 43,7, not 43,75. Yeah, sorry, turning it into centimeters. Right, so this is meters, 43,75 centimeters. Right, and this occurs, I don't actually know, like, what is this? In the real life problem, what is this? Is it a wall? I don't know what it is. It's just some random line that we drew in the air. But yeah, like the closest that they will be 5/4 meters away from whatever this line is in the real context. I don't feel like writing that down. So what was the friend's claim? The friend says the vertical distance between the flight path DB and the flight path CA will never be less than 40 centimeters. So yes, they are correct. And even more specifically, it will never be less than 43,75 centimeters. Love it when our friends are right. Celebrate their wins. Awesome stuff. Let's see what the memo believes to be true. Yeah, so we agree on the first answer. We have 3.5 meters, 7/2 meters. And then for the next question, so they figured out the minimum, the turning point using the first derivative, so that's also a perfectly valid approach, and found that the minimum vertical distance is indeed 43,75 centimeters. So our friend was correct. Awesome.